Hello, this is Liz Mullen, and the purpose of this set of videos is to do a statistics refresher for the independent study supervisors to help out their students in preparation for completing their independent study. In this presentation, we're going to go through three major categories. First will be a general introduction of the statistics, and then we'll talk a little bit about descriptive statistics. That will be the first video. Then the videos 2, 3, and 4 will actually going to further break down the remainder of the presentation, where video 2 will be about hypothesis testing, video 3 will be about t-tests, and video 4 will be about correlation and chi-square. Go through and do a brief review. One of the major components our students really need to understand is the ideas of level of measurement. Level of measurement, if the students understand level of measurement, they're going to be able to understand what statistical analysis they do, because the level of measurement, nominal, ordinal, interval, and ratio, these are all determining, or if your independent variable is nominal and your dependent variable is ratio, it determines what statistical analysis is most appropriate. All levels of measurement work in a hierarchy, so they work from lowest to highest, where nominal is considered the lowest level of measurement, and then they increase in complexity as we go through. The lowest level of measurement, like I said, was nominal. Nominal breaks people into groups or categorizes based on basic characteristics. There's no ranking implied. So I broke up here to give you an example, 3 different majors: athletic administration, the doctorate in physical education, and advanced level coaching. So you have three different majors being demonstrated here. You could do things like gender would be an appropriate nominal variable, trained versus untrained would be an appropriate nominal variable, department, major, anything where no rankings imply. There's no higher order or lower order. Ordinal variable, unfortunately my slides get a little messed up, so I'm going to have to do a little bit of drawing here. An ordinal variable, the levels of the variable are now ranked, but there's no standardized scale. So what that would mean is it could be something like, if you're ranking placement, you could do somebody who finishes first place and second place in a race, where those first 2 finishers are nice and close, but then third place doesn't come in until a little bit later, and then you have a little bit longer wait till 4th place, and then 5th and 6th all come in right at the same time. So no ranking or no standardized scale between 1 and 2, 2 and 3, and 3 and 4 exists. So that would be a ranked example. The most common, however, is a Likert item. This is when people do the questionnaires. For example, what you see down here with the strongly agree, neutral, disagree, or strongly disagree. The difference between strongly agree, and we usually then provide numbers for this, where strongly agree equals a 1, an agree equals a 2, a neutral equals a 3, a disagree equals a 4, and a strongly disagree equals a 5. Well, the difference between 1 and 2, strongly agree and agree, is a subjective difference for that individual, and therefore the difference between 1 and 2 and 3 is not the same, as well as the difference between 3 and 4 and 4 and 5. Neutral and disagree and strongly disagree are not the same. So there is ranking here. Clearly, strongly agree is a higher level of agreement than agree, but there is no quantifiable standardized scale from person to person. In addition, I think an important component of this is to realize that if somebody were to circle in between, it wouldn't have any sort of numerical quantification. That you couldn't know if that's a 1.3 or if that's a 1.7 or 1.5. Extra layer of complexity, you have an interval scale. Here you do have the ranking, but a standardized scale does exist. So the difference between a 1 and a 2 and a 2 and a 3 is the same. However, we don't have the existence of a meaningful 0. Let me come back to the meaningful 0 standpoint, but let's talk about now that standardized scale. Here, if we look at my example that I have to the right here in temperature, we have the difference between 20 degrees and 30 degrees is the same as the difference between 30 degrees and 40 degrees. We know that those things are standardized, so it does not matter what day I look at the thermometer, If I see 15 degrees, it's 15 degrees on one day is the same thing as 15 degrees on the next, and so on. However, if you look at the 0 points, the 0 points here and the 0 point down here, they're relatively arbitrary. And what they do not represent is the lack of temperature. If it's 0 degrees Fahrenheit, we feel cold. If it's 0 degrees centigrade, then we know that water freezes at that point. So all that they represent some other component, but they don't represent a lack of the variable. That's what a meaningful zero is, total lack of a variable. We're going to see that in the next example. Beyond temperature, the most common form of interval level of measurements your students are going to see is if you take those Likert scales, so those strongly agree, and what have you, strongly agree, neutral, disagree, strongly disagree, and let's say you have a 10-item scale like the Rosenberg self-esteem scale. You take it and you average those 10 items, each of them ranging on a 1 to 5 scale, 1, 2, 3, 4, 5, and you average those items, the average equals 2.12. Well, now I know where the 2.12 falls on my scale. It falls somewhere around here. And the difference between 2.12 and 2.42 is quantified. So by summing or averaging a Likert scale item, you've now created an interval level of measurement. So all of those standardized questionnaires that your students are using, those fall under interval. And then finally we have ratio. This is pretty much one of the more simple ones to understand. It's very basic, it's very common used in our fields. This is where we do have a standardized scale, but it has a meaningful zero. So if you have a 0, then it means the lack thereof. If you are holding a weight that is 0 kilograms, then you don't have a weight in your hand. If you are 0 inches tall, then you have no height. You don't exist. If you were asked to move forward 0 steps or 0 feet, then you did not move whatsoever. So ratio here, that meaningful 0, nothing. There's no no movement, or basically meaningful 0, a complete lack thereof. I will make an important note here. While I distinguish in this lecture between interval and ratio, statistical analysis do not. All statistical analysis that require parametric statistics, their interval also require or could do interval or ratio. They just require the standardized scale. The meaningful 0 is not a big deal in the long term. So where we're going to take this lecture over here is breaking down the difference between descriptive statistics and inferential statistics. Your students are going to be expected to be able to do both, where descriptive statistics are used to describe the sample they are working with. So if they collect data from 30 participants or 50 participants, they should find out or report some descriptive statistics, maybe the average age, maybe the number of people who were on the swimming team versus the basketball team, something along those lines. So they should have some description of their participants. Inferential statistics is where they take information about their sample and make some generalizations back to the population. So if you take information about Springfield College employees, or a sample of 30 Springfield College employees, you might be able to generalize back to a population of the entire Springfield College employees. We're going to spend the rest of this presentation just talking briefly about descriptive statistics. So there are 4 different types. The first is summaries of data. This is any sort of graphs and tables the students put together. They can be very helpful, especially graphs are very helpful in their posters, bar graphs, pie charts. I'm going to show each of the appropriate graphs for the inferential statistics as we move through the later presentations. Central tendency, this is your mean, which is the average of all scores, the median, which is the middle score, and the mode, which is the most frequently occurring score. Most often students are going to report the mean. However, what I'd like you to do is really encourage them to also report the mean plus or minus a standard deviation. And that's taking a measure of variation or dispersion. Variation or dispersion, the 3 options are range, standard deviation, or variance. Variance is a really helpful statistical number, but it's not very good for reporting data, so we're not going to report variance. Range, pretty easy, high minus low. Standard deviation, what we know about standard deviation is if you take the mean plus or minus 1 standard deviation, what that refers to is approximately 68% of your sample. And as you add to that, if you take mean plus or minus 2 standard deviations, that makes up 95% of your sample. Mean plus or minus 3 standard deviations is 99% of your sample. It just gives the reader extra information. If you just report means, you could have 2 different studies that have the exact same mean but have a much wider variability, where, for instance, I show an example where I have 2 different classes where the mean of their test scores was 71.5, but in one of the classes all the students scored in the 60s and 70s, and in one of the other classes the range goes from 42 to 100. So having variation is a pretty important component. And then the last one, probably least commonly seen in independent studies, would be talking about measures of position. That's your percents and your standardized scores, like your z-scores. They can be helpful, and if your students are interested in doing that, just have them chat with me. They can be helpful in some certain situations. And then the final thing that we're going to talk about here is that results should definitely include information on the sample using descriptive statistics. So should talk about the participants' descriptive statistics. You might want to give or encourage your students to talk about overall averages of their key dependent variables. If they're working with categorical data, that's their nominal or ordinal data, then they should be using n's and percentages and referring to the number or the count. And if they're doing continuous variables, so ordinal, interval, or ratio, they should be reporting mean plus or minus a standard deviation. So that's it for the introductory video. Remember, video 2 is going to be all about hypothesis testing, video 3 will be about t-tests, and video 4 will be about correlation.